Good morning, everybody. If there is ever any question as to whether or not Mr. Bechtel really appreciates his students in the AP Prep Model 2 class, it should be completely evidenced by the fact that currently this is Sunday morning and there's a storm outside, and I woke up and got this stuff together so that I could put together videos for you to review for your final. So if there's ever a time that you question, just recognize no. Okay, so here's what we're going to do. I'm going to put this full screen. There we go. That's full screen. And what we're going to be doing is talking about chapter 8. I'm going to try to do one of each of these for chapter 8, 10, 11, and 16. I'm not sure that I'm going to get them all done when you get to see the glory of uh, first thing in the morning Sunday, Mr. Bechtel, but that should be okay. So what I tried to do is I took a look at the final. I'm cutting down to the things that I think are the most important for you guys to know from each of these different chapters so that we can kind of review the material that you're going to need and get you to the place where you'll understand it enough that if you need to go back to the book and do some practice, you can do that too. So the first types of things we were talking about were variation and proportion. And we haven't had a chance to talk about those for a little bit. So I do want to make sure that we get to that. When we're talking about direct variation or direct proportion, what we're really talking about is solving an equation in such a way that the relationship between those things, it's a constant when you divide the two things that are directly proportional. And the example that they have here, when they say varies directly as proportional to, this means that in whatever situation they've given, if I have two different ideas, x1 and y1, it would be the same as x1 and y2 if y is directly proportional to x. And generally, what tends to happen is that you get the question of like, does it matter which one you put on top and which one you put on bottom? When you're just solving direct proportion, it really doesn't. We start to talk about joint and inverse variation. We got to think a little bit about where we put things. But for direct, it really is just set up a fraction. As long as you're consistent, it's fine. So like, for example, when we're looking at a problem, I just picked a couple here that were going to be easy and quick ones for us to talk about. If W varies directly as Z, first thing that I would do would be to set this up and just say, okay, I see the directly part. That lets me know that I'm going to be setting up a fraction. And so I'm just going to set up W over Z as my sort of, we're going to call it our guide fraction, like the template that we're going to use to set up all of our proportions. So then they tell us that W is 4.5 when Z is 3. So if I'm using this as my template, I'm going to do 4.5 over 3 because W is on top and Z is on bottom. Find Z when W is 1.5. So I'll put 1.5 on top and Z on bottom. Now, if you're just solving straight up proportions like this, you're cross multiplying. It's the easiest way to do it. And so in the case of something like this, we will multiply this direction, and we're going to say that 4.5 times Z is going to equal 3 times 1.5. That means that 4.5Z is equal to 4.5. Now, guys, I know you know how to divide these things, but the answer to this is that Z is going to have to equal 1, and it's pretty easy to do. When I created this review worksheet many years ago, I did not give a lot of space. I gave a lot of problems. So in the case of something like this is just to give you an idea as to how to do it. I know that you can show more work if you needed to, but this kind of gives us the idea as to how to do it. The thing that they can do is set something up as a direct proportion to a different function. And so like P being directly proportional to Q to the third power, it means that when you set up your proportion with a P on the top, you will have to make sure that you put Q to the third power on the bottom so that whatever you're plugging into there, you are cubing as you get that done. And it's not difficult to do. It's just something where you've got to remember it from the jump so that you understand how to set everything up. So here, 3, P is 3 when Q is 2. So that means 3 over 2 to the third power. Find P, so that'll be on the top, when Q is 4 to the third power. Okay, so guys, evaluate these. I mean, don't just leave them in exponential form unless it's a variable. So in this case, we will have 3 over 8 is going to equal P over 64. When we cross multiply, we're going to get 3 times 64 is going to equal 8P. I actually don't know 3 times 64 off the top of my head, so I'll be using my calculator on my phone to put that one together. 3 times 64 is 192. So what we'll get is that 192 is equal to 8p. And if I divide both sides by 8, I will get that p is equal to 24. These are pretty easy problems to solve, but they are going to be kind of the way to set them up. And when you talk about direct variation, you are talking about setting up a fraction when you're doing it, because the constant that they have for a direct proportion or direct variation is the ratio between the two values that they're talking about. Now, we got to go to inverse and joint variation. The difference being that when you talk about inverse variation, it means that you're setting up a product. The constant for these is the product of the two things. And if it's joint variation, it essentially means that you are directly proportional to more than one thing. So the inverse one's pretty easy. You just set them up as a multiplication. But when we talk about joint variation for something like this, it just means that you've got more than one thing that's on the bottom. This means direct. Now, you can do a lot of things together with this, and we're going to set up things in more than one way to sort of show you the jointly proportional, the inversely proportional, and then I'm going to do something that's combined with all of them. So we kind of get the full gamut of all the stuff that we could see. Okay, so I'm going to use 13 as my first example because I think it's a pretty easy one. So we have z is inversely proportional to j plus 2. Okay, so that means that the constant that we are setting up is z times j plus 2, because when I see inversely, I'm thinking of a product between those two things. So we're just setting up an equation where we have these set up equal to each other. So j is 10 when z is 8 for the first part. So we have 8 times 10 plus 2 is equal to, find j when z is 3. So this will be 3 times j plus 2. Okay, I am going to combine things here. So this is 12. And 8 times 12 is going to be 96. And here I'm going to distribute the 3 to both, so I get 3j plus 6. Okay, so the next thing I'm going to do here to solve for the j is to subtract 6 from both sides, and I'm going to get that 90 is equal to 3j. And then if I divide both sides by 3, I'm going to get that 30 is equal to j. So it's not hard to set them up. It just takes a minute to be able to get them together. Okay, so just make sure inversely proportional, you're just setting up a product. This was the z times j plus 2. We're figuring it out. Guys, that's my cat. Let me run her out of the way. Say hi. Okay. Now, next thing we've got to talk about is joint variation. And so like if A varies jointly as B and C, we're going to be talking about this from the perspective of having an A on the top of the fraction and a b times c on the bottom of the bracket, because it's directly proportional to both. Now with this, because the first one varies jointly as two additional things, the order of where you put these things does matter. You want to put the first thing on the top and the two other things on the bottom. I suppose it's possible that you could put the product of those on the top and the a on the bottom, but really just being consistent because of the way that most of these are going to be written, this is the way that I would suggest doing it. As we do this, then I'm just going to start plugging the values in. So A is 100, when B is 20, and C is 10. All right. Find A, which we don't know, when B is 60, and C is 30. All right. Multiplying it out, man. We have 100 over 200 is equal to A over 18,000. Make sure I didn't do that wrong. No, I did that right. Okay. I was like 1,800, not 18,000. I was like, man, that sounded so big. That's Sunday morning, guys. Okay. So we cross multiply here. And now we're going to get 180,000. Count 2, 3, 4. Yep. Is equal to 200A. And then if we divide both sides by 200, we get, let's see, the zeros cancel. It's going to be 900, I believe, as the final answer for that one, for what A is equal to. Now, look, as you look at something like this, I mean, the numbers are going to get big, but it's really not a difficult problem with what we're doing. When we do talk about something like problem, let's go with 17, because I kind of like the way that that one's put together. You've got inverse and joint variation occurring at the same time. It's just a lot of stuff to put together. So let's make sure that when we write it down, we're writing the correct template at the beginning to figure out what it's going to be. And I am a little cognizant of my time here. So I'm going to do problem 17, set up problem 18, just to kind of show you what the difference would be. And then I'm going to move on to the other things that are from this chapter that we need, because there's kind of a lot in chapter 8. Okay, so when we look at something like this, if A varies jointly as B and C, I'm going to stop before I do anything else and set up exactly that same problem that I had done before. A varies jointly as B and C. You guys can't see that. You can. If it varies inversely as D, that means I go back to where the A is, realizing the inverse proportion means that we're doing a product, and I'm going to put that directly next to it. So really what I have is I have a fraction that is made up of a product on the top and a product on the bottom based upon the inverse variation with D and the joint variation with two things, B and C on the bottom. All right, I got some plugging in to do. A is 4, when B is 5, C is 2, and D is 2. So I'll put everything where they're supposed to go. Find A when B is 12, C is 4, and D is 9. Yeah, these ones take a little while. So this will be 8 over 10 is going to equal 9A over 48. We cross multiply. We're going to get that 90A is equal to, let's just do what 48 times 8 is, friends. 48 times 8 is 384. Then if I divide them both by 90, I'm going to get, now, my calculator here is not going to do this in terms of fractions well. So here's what we're going to get. It gave me that A is equal to 4.26 repeating. And I could convert that right now, but you guys are going to have calculators that are going to do this in decimal or in fractional format. This is okay for me to start. And that's what I got for this. Let me check all my stuff to make sure I did it right. Oh, C is there, D is there. Yeah, that's right. And 8 times 48 is 384. So we did everything that we're looking at right here correctly. It's just that it was kind of an ugly answer. And that's okay. I mean, some of the answers are going to be ugly. And this kind of gives us an idea as to sort of how that would work. Okay. I'm just going to set up the way that the 18 is, and I'm not going to plug it in just because it takes a little while. So if R varies directly as P, since R over P, and inversely as the square root of Q, that just means that the inverse goes up on the top like that. Yeah, I mean, it's not hard to set up. You just have to get used to doing it, and we haven't spent a lot of time doing it recently. Okay, so then the next thing that we want to talk about is polynomial long division and polynomial synthetic division and how they get used. And I'm going to try to do these kind of quick, but man, they take a little time. So when we're looking at this, I'm going to do one of these where we've got one that divides straight out, and then one where we're dividing one by 3 different terms to talk about what's happening. Now, I got to be honest. I don't remember when I wrote these if these are going to have remainders or not. I may have just thrown a bunch of stuff together to see what's going to happen. If they have a remainder, we'll talk about what to do. If they don't, well, talk about what that means too. So when I set this up, I'm going to use another paper for it because I clearly didn't give myself the space. So when I set this up for this problem number 24 that we have here, we're dividing x to the 4th, 5x cubed, 6x, negative x, 6x squared, negative x, and minus 2. Notice there's no gaps in that at all. So we're just going to write them out, divided by the binomial x plus 2. So when it's long division, put an x plus 2 out. All of this on the inside, so x to the 4th plus 5x to the 3rd plus 6x squared minus x minus 2. Now, the parts about this that are important, in both what you're dividing by and what you are starting with, there cannot be any gaps in terms of our powers. So if I have 4, I have to go 3, 2, 1, and the constant doing that. Same thing here to the first power and a constant. I have them all, but if you don't, you have to put in a 0 term to make sure that it fits. The other thing that I want to remind you is that when you're asked to divide something like this, when you divide at long division, you can always use long division, but in a case like this, because we're dividing by a binomial, I could use synthetic for division when we divide by something like this one, because we're just finding out what the 0 is and plugging it in. But for the sake of this, we're just going to kind of say, this is good. We'll leave it from here. Okay, so the first thing that you're going to do is to realize that when you do this work, our goal each time we're multiplying by something is to cancel out whatever this first term is. So I need to get rid of x to the 4th power. That means I'm going to have to multiply that x times x to the 3rd. And that's where I'm going to put it. So I'm going to multiply it by an x to the 3rd, put it over here. I really kind of think about it as because there's 2 terms outside that I'm dividing by, I'm going to go 2 terms in. And I'm going to subtract that off. So x to the third times x is x to the fourth. But I also have to multiply it by the second thing here. So x to the third times 2 is positive 2 x to the third. Now, if we did it wrong, then these wouldn't cancel out. But every time we do this, we are leaving away one of those and writing what's left. So x to the fourth minus x to the fourth, gone. 5x to the third minus 2x to the third is 3x to the third. And then like all long division, we just bring the next thing down, plus 6x squared. Now I'm just going to keep going across and doing this, and I'll talk about why I'm doing it the way that I am as I do it, but I'm going to be a little bit less descriptive. I'm just going to kind of show you what's happening. Okay, so now I got to cancel a 3x to the third times the x, so I'm going to do this times a 3x squared. We'll be subtracting that off, so 3x squared times x is 3x to the third. 3x squared times 2 is 6x squared. This is going to be an interesting one because that goes away and that goes away. So we have a 0 x squared. What that means is that when I bring this next thing down, that negative x, I'm not going to be multiplying it by anything, because in the case of this one, this would be like multiplying by a 0. And I'll put it here because it's what would happen, but like we just have what's left. So I'm going to actually move to the next one and bring the next thing down as well, because I only have two terms here. Since I didn't have an x squared, I've got to have these two. So now I've got x plus 2. I want to get rid of that negative, so I'm going to multiply this by a negative 1. In here, we will have a minus. So negative 1 times x is negative x. Negative 1 times 2 is negative 2. And when I subtract this, I get a 0 for that one, and I get a 0 for this one. So there is no remainder for this. Our answer that we will have when we are done is this. Now, I would probably just write x to the third plus 3x squared minus 1, because you don't generally include your 0 term. But that is the result that you get when you divide those two using long division. Now, shouldn't be too much of an issue for you to do. And in this case, we know that since we didn't have any extra, we don't have to do an extra thing at the end. But if we did, we would put this at the end over whatever it is that we divided by. Now, it's a 0 over x plus 2. So again, we don't need it. But anytime that you get a remainder here, that always goes on the numerator of a fraction, and then the denominator is what you divide it by. Okay, I wanted to do one that we divided by a 3-term polynomial just to kind of show you. And if you look at the top, you'll note that there's a couple gaps that we have in here too. I'm kind of hoping this gives us a remainder so we know what to do, but it'll be okay. So we're doing problem 25. We will have those 3 terms on the outside here because we are dividing by x squared plus 2x minus 5. And then I'm starting with an x to the fourth. I'm going to work my way down. So I don't have an x to the third. I'll put a 0. I do have an x squared. I don't have an x, so I'll put a 0. And I do have a minus 3. Stupid cat. Cat hair on my nose for picking the cat up and setting it down. Anyways, okay, so this is everything that I had. And so here we go. X squared, and I want to cancel out x to the fourth. So that means I'm going to multiply it by just an x squared. Now, I always line them up with what I multiply by because that's the way that it works. But I also want you to note, because I have 3 terms here, it's got to fit with the 3 terms that I have here. Okay, so I will be subtracting off what I get. This will be x to the fourth plus 2x to the third minus 5x squared. Okay, subtracting down, gone. 0 minus 2x to the third power is negative 2x to the third. 4 minus a negative 5x squared is going to give me a positive 9x squared, because when you subtract a negative, it becomes a positive. I'm going to slide down that 0x, which is, again, fine. We have the 3 terms here, and that's what would represent what we have at the end. We're going to be subtracting off just like we did there, but I need to have 3 terms because I have 3 terms on the outside. What I would have to multiply x squared by to cancel out negative 2x to the third would be a negative 2x, which is nice. So I'll subtract that. Negative 2x times this is negative 2x to the third. Negative 2x times 2x is negative 4x squared. Negative 2x times negative 5 is positive 10x. So now I subtract. Go on. 9 minus negative 4 will give you 13x squared. 0 minus 10 is going to give me negative 10x. And then bring that negative 3 down at the end of this one. Pretty sure we're going to have a remainder for this guy. Okay, so to get that 13x squared canceled out, I will have to multiply this by a 13. And when I multiply that across, I will have 13x squared plus 26x minus 65. Yeah, there will be some solid remainder for this one. These two subtract, gone. Negative 10x minus 26x is negative 36x. Negative 3 minus negative 65 will be a positive 62. So this is my remainder. What we then do with the remainder is we put that at the end. So I'm going to be adding a fraction. I put whatever is down here on the top of the fraction, even though it's a negative. I'm just going to put that on the top. And then what I divided by here, that's going to go on the bottom. So x squared plus 2x minus 5. Now, is that an ugly answer? Yes. Yes, it is an ugly answer, but it's okay. This is the most accurate answer that we have. Now, somebody had asked the question as to whether or not our final was going to be multiple choice. And yeah, the math accuracy portion is going to be multiple choice. So it is a possibility that one of these answers could have brought that negative out to the front as a minus, and it would be a positive 36x minus 62. But you guys know enough about how that stuff works that I'm not concerned you won't be able to do it. Now, the synthetic division is where we get the much, much faster versions of this, which I kind of like. As we look at it, ultimately, when we're doing this, what we're actually doing when we divide by this is we discovered that it is a faster way of doing it to be able to say, well, if I used the zero, the negative version of this, then instead of subtracting, I would be adding, and I'm really just dealing with the coefficients that we have. So what we do with a problem like 29 is we write what the zero would be for this denominator, because x plus 3, we'd have a negative 3. And then we'd put this out all the way across here, and I'd write just the coefficients. So 5, 18, 17, and negative 6. Now, just like what we did up at the top part, if we had anything that was missing, we'd have to put in a 0. But because we have all 4 of these, it's fine. And what I'm going to do is put a little space here at the bottom, because that's where my remainder will go. There may or may not be a remainder, but we'll see. All right, so I'll do the work here. The nice thing about these is I don't have to worry about all the x's and such yet. You just deal with the numbers. First thing you do is you bring that number down. Then you multiply the outside number times what we have down here and put it right back there. So negative 3 times 5 is negative 15. And just like I said before, because we are not subtracting each time because it's the opposite version out here, we will always add straight down. 18 plus negative 15 is going to give me a 3. Negative 3 times 3 is going to give me a negative 9. 17 plus negative 9 is 8. Excuse me. Negative 3 times 8 will put a negative 24 here. And when I put that down together, I will get a negative 30 as my remainder. Now, what this means, if I look back at the original problem, is that because I've divided out this first term, my answer here is going to be 1 degree less than my x to the third. So this is the coefficient of the first one. So it's going to be 5. Since it's 1 less, this will be x squared plus 3x plus 8. And I do have a remainder, so I'll write plus negative 30 over what I divided by here, x plus 3. So this is the answer. It surely takes up a lot less space, but it is a place of kind of figuring out what it is that you want to do with it. Okay, let me show you one other quick thing. And this is kind of a version of how you would work with it. And I don't even know probably what you're also going to do. There's this thing called synthetic substitution, where if they're asking you to find, I'll just make it up. So if I want you to find p of negative 2, and p of x is equal to 5x to the fifth minus 2x to the third plus 7x squared plus 1. They're asking you not just to plug in the negative 2 and get the answer, but to use synthetic division for it. One of the things that we realized before is that when we use synthetic division, it's the same answer that you would get if you just plug this directly into it with your remainder. So what you do is you put that negative 2 on the outside, because this is what we're plugging in. And so the synthetic substitution is saying this is what we'd have as our 0. And then we're going to go across. So we've got a 5, missing the fourth term, so that's a 0. Negative 2, 7. I don't have an x term, so there's a 0 and a 1. And so then what we do is we go through and we are going to be just doing synthetic division. Whatever our answer here is the answer that we would get for if we plugged in a negative 2. I'll let you guys check that. 5 down, negative 2 times 5 is negative 10. 0 plus negative 10 is negative 10. Negative 2 times negative 10 is 20. Negative 2 plus 20 is 18. 18 times negative 2 is negative 36. 7 plus negative 36 is going to be negative 29. Negative 29 times 2 is positive 58. 58 plus 0 is 58. 58 times negative 2 is negative 104. And if I add that to a 1, negative 100 is 3 is the answer. So negative 103 is what we would get when we plugged it in. This is just a version of synthetic substitution. Wanted to make sure you could see it so that you could go, okay, well, now I understand how this is supposed to work. Okay, there's only about 2 more things that you're going to have to look at from this unit. One of them is kind of a fast one. And I am going to tell you, you're not going to have to do the whole thing because the final is going to be a little bit crazy. It's sometimes that you've been asked to be able to find roots for things. And so, like, what I wanted to show you really quickly is that let's say I gave you an equation that was like x to the fourth plus 8x to the third power plus 19x squared plus 2x minus 30 is equal to 0. Okay. One of the things that we used all of our synthetic division and our long division to do is to find some zeros, plug them in, get our answers for what's going to happen, and go through it. Sometimes what they'll do then is say, well, if I know that this is a root, what could we do to find the rest of it? And so these do take quite some time. And so, like, really quickly, I wanted to show you sometimes when they do stuff like this, they'll give you one like, let's say I give you that negative 3 minus I is a root. Okay, so here's one of the things that I want to make sure that you understand. When we start talking about the roots that exist for polynomials, if I have an imaginary, or they call this complex because we have a real part and an imaginary part, these occur in complex conjugate pairs, which would mean that if this one is a root, and it is, then its conjugate would also have to be a root, negative 3 plus I, because these come from us doing the quadratic formula to find the answer. And since all of those involve that plus or minus part, we are going to be getting more than one of these because the imaginary part has a plus or minus thing that has the I part to it. Now, if we were going to put these into a format where I had to divide it out, the 2 roots that we would actually have would be in the form x minus for both, and then you would just say what the root was. So x minus negative 3 minus I, and x minus negative 3 plus I. Now, again, you're not going to have to do that for these, but this is something that if I wanted to do this, I'd have to multiply all of this out. We have to find it. Now, that was definitely something that was on your earlier test, which is the reason why, since we're doing everything from the semester, we're not going to do that. But it is important to recognize because you may have something, considering the fact that these are going to be multiple choices, that if I give you one root, being able to identify another one would be a good one. And the fact that these occur in complex conjugate pairs is an important thing to remember. Now, for the last thing that I want us to be able to do is that sometimes what they'll do is just give you an actual equation, and then they'll ask you to find all the possible roots and then start looking for them. So if that's the case, this is called the possible rational root theorem. Oop, let's write it down the right way. Possible rational root theorem. And what that means is that when I have a polynomial and it's set equal to 0, the possible rational roots, meaning the fractions themselves, take the format of this. It is all of the factors of the constant, so the term that does not have an x, divided by all of the factors of the leading coefficient. And so what I'm going to do right now is I'm going to show you what that looks like with an equation. So if we're doing this, let's say that I have the equation 3x to the fourth power plus 2x to the third minus 15x squared plus 8x minus, let's go 12 is equal to 0. All right. Now, if this is all I'm given and I have no idea what they are, I'm going to need to start to find possibilities to divide them out. Now, again, this is a process that takes an extraordinarily long time because you have to write them all out. You got to divide them all out. You got to check them one at a time to see which one works. And in this case, what we're going to want to do then is to be able to have us just write our possible rational roots. And then we'll figure out sort of what we would do from there. First thing that you need to be able to do then is to list your factors. So the factors of the leading coefficient, because that's the first one that I'm looking at here, well, it's 3. So we're going to have positive, negative 1, and 3 that go into this. Then if I want my factors of the constant, still positive, negative, and we're looking at 12. Well, the numbers that go into 12 are going to be 1, 2, 3, 4, 6, and 12. That's a lot of factors that we have there. So that when we're doing this, if we want to write all of the possible rational roots, what we're essentially going to be doing are the positive and negative versions of every combination when we have the factors of the constant on the top. So 1, 2, 3, 4, 6, and 12. And that's going to be over the factors of the bottom, 1 and 3. Now, this is going to be a little bit of an extensive list, and we've got to do a couple things to kind of think them through. But ultimately, if you're just listing them out, what you're trying to do is to narrow down your possibilities of what we could use for this to find out if it's a zero from everything to a limited number of what's going to work. And then you just try them one at a time until they go. Not on the final, because it takes too long, but if we were to use this in another place. So I do these by basically putting all of these over 1 first, and then putting all of these over 3 second. So we've got positive or negative. Now I'm just going to keep it out front. They've all got positive or negative, so let's just do that. Positive and negative, 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12. Okay, we have our whole numbers. Now let's do the fractions. Some of them are going to reduce to something we already have, but let's make sure we do it. So now we're going to have 1 over 3, 2 over 3, 3 over 3 is 1, so we don't need to write that. 4 over 3, 6 over 3 is 2, don't need that. 12 over 3 is 4, don't need that. So this is my final list of all my possible rational roots. Now, you could take these and start plugging all of them in by using synthetic division to see which ones actually come out. And when it does, you would then go down and make another list of your possible rational zeros until you got to this being squared, and then you'd use the quadratic formula to solve it. But again, right now, it's just the idea of, can you check this? When you're starting to plan for a final, what you want to start thinking about are, what are the faster ways of doing this? And do you have something like this to be able to go out and see, did I do this right? Are these possible rational zeros, and what happens? Again, it's a possibility that none of them. But in the case of this, what our real goal is to say, okay, if we've tried all of them, this is our place to start. Okay, and I think, since I've talked for a really long time, that's probably enough for what we're going to be doing for Chapter 8. So enjoy the rest of your day.